This is a review of probabilities for Opry 202. So let's get started with 5 marbles. This is our entire sample space, and in the event that I pull out one marble at a time, each of those events together are collectively exhaustive. So let's say I pull out marble C, and we know that it's blue. So there are 2 events of interest at play. I just pulled out marble C, and at the same time, I just pulled out a blue marble. So because both of those are events of interest, we can say that this is a joint event. Because the event or the marble is described by 2 separate characteristics. The fact that it is marble C and the fact that it is blue. If we just pulled out a blue marble with no concern for the letter that it has, then it would just be a simple event. Or if we were just concerned with the letter of the marble that we pulled out, it would also be a simple event. So it depends on what characteristic we are interested in at the moment. Let's say we were interested in pulling out marble C. It just so happened to be blue, but our event of interest is pulling out marble C. And the probability of this happening is 1/5. So we simply counted all of the marbles, and one of them is C, so our probability is 1/5. This is the simple probability. Now the difference here with marginal probability is that there's a formula at play, but you're going to get the same probability. So marginal probability. So the marginal probability of C, or getting a marble that's labeled C, is the probability of C and the probability of getting a blue marble plus the probability of C and the probability of getting a pink marble, which is here. Let me go ahead and fix that. C and pink. Now, because the blue and the pink make up our entire sample space, they are mutually exclusive and collectively exhaustive, which make it correct for our marginal probability. So now we can calculate it. 1/5 is our probability of getting C, and 3/5 is our probability of getting blue, plus 1/5, 2/5, and we're multiplying. Now we'll see some math magic happen, because we can simply go 3/25 plus 2/25 equals 1/5, which is the exact same probability that we had here. So when you think about marginal probability, just know that it is the same thing as simple probability, but it uses a formula to break up other factors that are both mutually exclusive and collectively exhaustive, but it breaks up those other factors that exist in the sample space. So if we have probability of getting a marble C, the other factors that might exist in the sample space is the color. So we can break up the color into 2 parts, and it could be more parts, and that makes up our margins in the marginal probability formula. Similar to what we saw in class, the probability of it being Wednesday, we can simply say, well, 52 out of 366, I simply counted the days, and there are 52 Wednesdays. Well, we can also break up our formula, or our probability of Wednesday, into margins of January or not January. And that would be probability of Wednesday and look, it's a marginal probability formula. So you'll get the same probability, but it's just 2 ways of viewing this probability. And when you get to more complex probability problems, this breaking up of an event into margins based on other events in the sample space is really helpful. Now let's move on to using the addition rule and the multiplication rule in this situation. So with the addition rule, we are using the keyword or. And let's say that we want to get either marble A, which is blue, or we want to get any marble that is pink. Okay, so we can simply use a formula, the longer formula, to help us out here. So let's replace our events. Event A is, let's say, just marble A, and then event B is getting a pink marble. And we can count and see what these probabilities would be. So the probability of A is 1/5. The probability of B is 2/5. And this one is a little interesting because the probability of A and B, it can't exist. Because if I'm pulling out one marble, it is impossible for me to pull out marble A and for it to also be pink. So the probability of this is 0. So now we can just add these, which gives us a probability of 3/5. Now, we could have easily just solved this using this equation. Probability of A or B equals the probability of A plus the probability of B, and completely disregarded this part. And that is because these two events are mutually exclusive. And this means that they cannot occur at the same time. So because of that, we can disregard this portion of the formula. Okay, now let's look at the event where I pull out 2 marbles at the same time. So now that allows us to play with the multiplication rule, which is based on the keyword and. And let's keep the same marbles that we had. So marble A and any marble that's pink. So marble A is blue, any marble that's pink. And our keyword is and. So because I'm pulling out 2 marbles at the same time, it is possible and ideal for me to get marble A and any marble that's pink. So the fact or the characteristic of being mutually exclusive is not the case here. Mutually exclusive. Because that would mean that they can't exist at the same time. But in this case, they can. So now let's go to our formula. Like the or addition rule here, this formula can also have a replacement based on a characteristic. So we can replace this with probability of A. Why? Because the 2 events of pulling out A and pulling out any marble that's pink, they're independent of each other. That's because I'm pulling them out at the same time. So they don't affect the probability of one another. So they are independent. Because they are independent, we can replace PA given B with probability of A. So now let's use our new formula. Probability of A and B equals the probability of A times, or we can just do that, probability of B. And then let's just plug it in. So probability of A is 1/5, because that is the probability of pulling out marble A. And then the probability of pulling out a pink marble is 2/5. And now we multiply it. So 2/25. And this is our final probability. If we wanted to ask, what is the probability of pulling out marble A and any pink marble? And if we're comparing the addition and multiplication rule, we see that when you have or, you are increasing your options of what is considered acceptable. For example, here, it is considered acceptable or considered a success for me to pull out either marble A or 2 of either two of the pink marbles. So we have three options here. Whereas in the multiplication rule, we're limiting the amount of options that we'll consider a success or something that's acceptable. The only thing that we'll consider a success is pulling out marble A and one of the pink marbles. So the probability of that happening is much less. So that's the relationship between the multiplication and addition rule. You're usually going to get a more restrictive probability when you're using multiplication, and a less restrictive probability when you're using addition. So that's a few ways of looking at those rules.